Hello, everyone. I wanted to make a quick video for you to help with some of the required topics in Homework 11 that we did not get to. Um, so, yeah, let's just get right into it. So the properties of logarithms that we did not get to in class are the product rule, the quotient rule, and the power rule. Basically, the product rule says that if you have log base b of a number m times a number n inside a logarithm. So if you have multiplication happening inside a logarithm, then basically what you can do is this is the same as log base b of m plus log base b of n. You can add their separate logarithms. So here m and n are being multiplied inside one logarithm. Here m is in its own logarithm, n is in its own logarithm, and they're being added. And basically, um, the reason that this works, I don't want to get too far into it because I think that'll just be more confusing and it'll get us off track. But basically, if you multiply two things, you add their exponents. Um, that's basically how this is all connected and why this property works. Because at their core, logarithms are exponents. So if you're multiplying two things, two exponentials with the same base, then you add their exponents and keep the same base. And that's basically what this is. These are each individual exponents, so you can add them. But basically, big thing I need you to take away from this, multiplication inside a logarithm turns into addition outside separate logarithms. Okay, so the quotient rule is next. Quotient means division. So this time we have division happening inside a logarithm. So if we have m divided by n inside a logarithm, if we divide two exponentials with the same base, then we subtract their exponents. And so division inside one logarithm turns into subtraction outside. Again, here the division was happening inside one logarithm. Here the subtraction is happening outside separate logarithms. I do want to make a quick note here. Slide over here. With the subtraction here, I just want to make sure that you know that order matters here. You need to make sure that you do log base b of the top minus log base b of the bottom. It's always top minus bottom. Order does matter. So just be careful with that. The one on top goes first, the one on the bottom goes second, and they're connected by subtraction. And then the last one is the power rule. So we are going to use this one if we have a power happening inside a logarithm. So let's say we have m to the p power inside a logarithm, then what we can do is multiply that p on the outside, and we're going to multiply it by log base b of m. So visually, what's happening here is that this exponent can be dropped out front, and then it's being multiplied once it gets out front there. Again, this goes back to the properties of exponents. If you have an exponential to a power, so powers to powers, you multiply the exponents. Log base b of m, this is at its core an exponent. If you have something to a power, you multiply those two exponents. And again, you don't have to know exactly why these work. Biggest thing is that I just need you to make sure that you kind of know how to operate with these. So multiplication inside turns to addition outside. Division inside turns into subtraction outside. Powers inside turn into multiplication outside. So let's see if we can figure out how to use these. So we want to use these properties of logarithms to write each expression as a sum or difference of logarithms. So we have a single logarithm, and inside is complicated stuff, and we want to try to simplify it to a bunch of logs being added or subtracted. So in number one here, log base 8 of 13y. What operation is happening inside the logarithm here? It's multiplication, right? The 13 and the y are being multiplied. That's 13 times y. And so since we have multiplication inside, we're going to use the product rule. And so what we're going to do is this is log base 8 of 13 and log base 8 of y. We're going to take their separate logarithms, and multiplication inside turns into addition outside. So we can turn log base 8 of 13 times y into log base 8 of 13 plus log base 8 of y. All right, let's try number 2. Log base 5 of 125 divided by x. So what operation do we have in the inside here? Yep, it's division. So division inside turns into subtraction of their separate logarithms. And again, order matters here. So we're going to do log base 5 of the top, which is 125, and we'll subtract from that log base 5 of the bottom, which is x. It's always top minus bottom. All right, how about number 3? Log base b of x to the 7th power. What operation do we have inside the logarithm here? Well, we have a power happening. We have x to the 7th power. That's this guy right here. And so basically what we're going to do is we're going to take that exponent and drop it out front. So this 7 is going to come all the way out front. And this is going to turn into 7 times log base b of x. Just take the exponent and drop it out front. All right, how about number 4? ln of the 7th root of x. Okay, what do we have going on inside the logarithm this time? Well, it's a root. Can we represent that 7th root as either a multiplication, a division, or a power? Yes, roots are exponents. Roots are fractional exponents. So this is actually ln, or that's log base e. You can write it that way if you like, of x to the 1/7 power. Again, the index of our radical is 7, so that's the number that's going to go on the bottom of this fraction here. So ln of x to the 1/7, that's how we write the 7th root as an exponent. And now we have a power inside our logarithm, so now we can take that power and drop it out front. So this is the same as 1/7 times the ln of x. And now we're done. All right, let's keep moving. Now we're going to get into more complicated things. So number 5, log base 5 of the square root of x divided by 25. So here we've got division happening inside, but we also have a power happening inside, right? Because this is log base 5 of square root of x. That's a power. I want you to think of roots as powers here. So the square root of x is x to the 1/2 power. Again, roots are fractional exponents. If there's no index here, it's understood to be a 2. That's why we have a 2 here on the bottom down here. So we've got division and we have an exponent. So if we've got multiple things going on, then the order that I want you to do these things in is first, I want you to do the product of the quotient rule first. Always do those guys first. And then I want you to save the power rule for last. So if you got multiple things, do the products and quotients first, and then only do the power rule once you've split everything up and you only have powers and no multiplication or division inside. So since we have a power and division, we're going to do that division first. So the since we've got division, we'll use the quotient rule, and we are going to do log base 5 of the top, which is x to the 1/2, minus log base 5 of 25, top minus bottom. And so now we have everything split up here, and there's no more multiplication or division happening in either of our logarithms. So now we can go to the power rule. This is an exponent. It gets dropped out front. So this is 1/2 times the log base 5 of x minus log base 5 of 25. Now there's no rules that we can apply here, but log base 5 of 25, this is actually a nice number. This says, what this really means, log base 5 of 25, this says 5 to what power gives you 25? And the answer is 2. So log base 5 of 25 is just 2 because 5 to the second power gives us that 25. So if you can simplify like that, go ahead and do that. And I actually missed one up here in number 2, this log base 5 of 125. That was another one that we could do. I totally missed that before. This one says 5 to what power gives me 125? Well, 5 to the first power is 5. 5 to the second power is 5 times 5, which is 120, or is 25, sorry, 25. And then 5 to the third power is 5 times 5, which is 25 times another 5 is 125. So we could have actually simplified this one a little further, and we could have written that as 3 minus log base 5 of x. So sorry that I missed that one before. Yeah, so anytime that you've just got numbers, look to see if they simplify. This one over here, this is log base 8 of 13. This says 8 to what power gives you 13? The answer is not a nice one. So if it's not a nice number and you have to put it in your calculator, don't worry about it. It's just a number, but it's not a really nice one, so we'll just leave it as is. But if it's one that simplifies to a nice number, like a whole number, let's go ahead and do that. I don't know that Alex is going to force you to do that on any of these, but it might ask you to. So if it throws you like an unsimplified answer, like if an unsimplified message, if it says that your answer is not wrong, but it doesn't like the format that it's in, just check to see if any of the numbers simplify, because it might want you to do that. Okay. Sorry for that little detour, and sorry that I missed that in number 2. Now number 6. Log of x to the 7th times y divided by z. Okay, we've got powers, we've got multiplication, and we've got division happening. So what we need to do is start with the product and the quotient rules and then go to the power rule. When we do the product and quotient rules, I actually like to do the quotient rule first. I think it's going to be the most helpful here. So let's take care of this division first. So it's going to be log of the top. And again, if you don't like it not having a base here, if the unwritten base is understood to be a 10, write it in if your brain likes that better. There's nothing wrong with that. So we're going to do log of the top minus log of the bottom. Again, you don't have to write that 10. Some people just really like having the base there to make everything consistent. Nothing wrong with that, but you don't have to write it if you don't want. Okay, so now we took care of the division. So division inside turned to subtraction outside. Now, do we have any multiplication or division remaining inside any of our logs? Yes, we have multiplication inside a log right here. So now we have to split that one up. So we'll apply the product rule to this one, If you've got multiplication inside, that turns into addition outside. So this is going to be log of x to the 7th plus log of y minus log of z. This multiplication turned into addition outside, and they each get their own separate log with the same base. Again, unwritten is understood to be a 10. Write it in if your brain likes that better. Okay, do we have any multiplication or division happening inside a logarithm? Nope, no more multiplication or division, but we still have a power, right? We still have this 7 right here. So we'll go ahead and apply the power rule to that, and we'll toss that out front. This is the last thing that you're going to do when you expand logarithms like this. This process we usually call expansion because we're taking one thing that's complicated and kind of expanding it out into a bunch of separate logarithms. Okay, so this is our final answer. Now, something that I want you to notice here, the x to the 7th and the y were both on the top. Their logs are positive here. The z is on the bottom. Its log is negative. Okay, just something that I wanted you to notice, and we will keep moving. Number 7, log base b of x to the 7th divided by yz. Again, the first thing that we're going to do are the product and quotient rules. If you have both a product and a quotient, which we do, we've got division here and multiplication here. Let's do the division first. So do the quotient rule, then any product rules that may be there. So this is going to be log base b of the top, which is x to the 7th, minus log base b of the bottom, which is yz. Okay, so we have the division taken care of now. Do we have any multiplication or division remaining? We've got some multiplication right here. So we're going to apply the product rule to that piece. And we are going to have log base b of x to the 7th minus, now we can split this one up with the product rule. So we've got a product inside. That's going to turn into log base b of y plus log base b of z. Now we have to be careful here because we were subtracting this whole logarithm. We need to subtract everything that came from that logarithm when we expand it. So we got to make sure that this negative gets distributed to each of those pieces because we have to subtract this whole thing and we need to subtract anything that came from it. So let's go ahead and distribute that. So we'll have log base b of x to the 7th minus log base b of y minus log base b of z. And then the very last thing, we still have an exponent here. We can drop that out front. And this becomes, sorry, I'm running out of space here, 7 times log base b of x minus log base b of y minus log base b of z. This is our final answer here. Here we go. And I get a lot of questions about parentheses, like here I included these in parentheses and I didn't down here. That's totally personal preference. If there are no parentheses, then basically just this next thing after the log base b part is understood to be inside the logarithm. But some people like to include that to just be 100% clear about what's inside the logarithm and what's not. It's totally personal preference. So whether you put parentheses around this x and the y and the z or not is up to you. But if there's no parentheses there, it's understood that the thing that comes after log base b is inside that logarithm. Because remember, log base b is a function. It's kind of like a root. And so it needs something inside it, right? Like an empty square root with nothing inside of it doesn't mean anything. That's the same thing as log base b with nothing inside of it. It's like an empty square root. It doesn't mean anything by itself. It needs something inside of it to make any sense. Um, so just don't forget to put something after the log to make it make sense to have something inside. But whether you put those parentheses there or not is kind of a personal preference. All right, number 8. And actually, before we do this one, I also wanted to point out, just like I did in number 6, um, in number 7, x to the 7th was the thing that was on top. Its logarithm is positive. And notice both y and z were in the bottom here. Both of their logarithms were negative. That's not a fluke. That's a thing. Anything that comes from the top should have a positive logarithm, just like it did up here. Both the x to the 7th and the y came from the top. Their logs were positive. Anything that comes from the top, their logs should be positive. Anything that came from the bottom, their logs should be negative. Y and Z in number 7, they were both from the bottom. Their logs should both be negative. And here in number 6, the Z was on the bottom. Its log is negative. Um, that can really help you start to make sense of these and check yourself to make sure that you didn't make any mistakes. And it's going to help us a ton when we go backwards and condense into a single log. So here in number 8, log base 2 of y to the 4th divided by x to the 3rd times the square root of z. We've got multiplication, we've got division, we've got powers all over the place. What do we do first? We do the division first. Let's do the quotient rule. We are going to do log base 2 of the top minus log base 2 of the bottom. And the square root of z, I'm just going to go ahead and make that z to the 1/2 power. Roots are exponents. The earlier we start to kind of see those as exponents, the easier it's going to make our lives as we go. So I'm just going to go ahead and change the square root of z to z to the 1/2 right off the bat. Okay, so we took care of that division. We turned it into subtraction, but we still have multiplication remaining in one of our logs. So let's go ahead and split that up. So this is going to turn into log base 2 of y to the 4th minus log base 2 of x to the 3rd plus log base 2 of z to the 1/2. And remember, we are subtracting this whole log, which means we have to subtract this whole sum, and we're going to have to distribute that negative. If you can kind of do that part in your head and you do it all at the same time and you jump right to here, minus log base 2 of z to the 1/2. If you jump right to here from here, I'm totally fine with that. But if your brain doesn't like that, then take the extra step, no problem. Just make sure you distribute that negative to each piece, because again, the x to the 3rd and the square root of z are both on the bottom. Their logs both need to be negative. Okay, so once we have that distributed, the only thing that's left is our powers. We don't have any products remaining inside a log. We just have powers. So we'll go ahead and take all of these powers and throw them out front in all of these pieces. And we will have 4 times log base 2 of y minus 3 times the log base 2 of x minus 1/2 log base 2 of z. And that is our final answer here. All right, one last one here in number 9. The ln of the 5th root of x y to the 4th over z squared. Okay, So all of this stuff, x times y to the fourth over z squared, is all inside a fifth root. And remember, roots are exponents. That's right. So we need to just, let's make this an exponent right off the bat. Oh, sorry, there shouldn't be an equal sign there. So this is all equal to the ln of x times y to the fourth over z squared. All of that's inside the logarithm, and all of this is to the 1/5 power. Because again, the fifth root is a 1/5 power. And since all of this stuff is inside the root, all of that is inside the exponent. So because this is all multiplication and division, we can distribute that exponent to everything inside. You can do this with multiplication and division. You cannot do this with addition and subtraction. So this is the ln of x to the 1/5 times y to the fourth to the 1/5 power. When you have powers, two powers, you multiply them. So that becomes 4/5 power, because 4 over 1 times 1 over 5 is 4 over 5 when you multiply across. And this is all going to be over z to the, again, you're going to multiply those exponents. 2 times 1/5 is 2/5 power. And so now that we've distributed that exponent to each piece, hopefully now you can see what we'll do here. And you'll split the division. So this will be the ln of the top. 5 times y to the 4/5 minus the ln of the bottom, which is z to the 2/5. And we've got multiplication in here, so we'll split that. So this is going to be ln of x to the 1/5 plus the ln of y to the 4/5 minus the ln of z to the 2/5. And now we just need to take all those exponents and drop them out front. So this is going to be 1/5 times the ln of x plus 4/5 times the ln of y minus 2/5 times the ln of z. And that is our final answer. All right, so that is how we expand logarithms. Again, we're using our product, quotient, and power rules. Do the quotient rule first, do the division, then apply product rules, and save that power rule for last. All right, I hope that helps, and have a great day. I'll do one more video for the condensing in just a minute.